How do you tell if you have an alkane? What?
The lack of functional groups.
Lack of functional groups. Here shortly I'll draw a picture of what I think is just an alkane. Right, so here we see carbonyl carbon, OH stretch. So this is carboxylic acid. Alcohol, this thing's moved over a little bit, like you correctly told me. So here's a carbonyl carbon, and here's a double bond that's adjacent. And so these are called conjugated, and they're special due to resonance. And so you see that these, instead of being at 720, they're a little below 1700, 1685. So here's a conjugated aldehyde. I wonder if I missed a slide with words on it that said conjugation shifts the stretching frequency a little bit over to the right. So here is another carbonyl carbon, normal ketone 1720, and we see that these go even further to the right, a little lower wave number than the conjugated carbonyl carbon. Notice that looks pretty conjugated. Instead of a double pi bond here for electrons, we got a lone pair on nitrogen, and that can move over. So here's a typical amide. The carbonyl groups of amides absorbs at particularly low, so the qualifier is low compared to other carbonyl carbons, 1640 to 1680. So here's an amide again. I put this in here so you can see that it is a tertiary, secondary, or a primary amine. What do you think? Yeah, primary. It's only bonded to one carbon. So we have two hydrogens. So the other day we had, my example just was kind of broad and had a little pointy part and a little pointy thing we ignored. This one's fairly dramatic. You can see both hydrogens. Here's our normal alkane thing we just ignore. Carbonyl carbon, normally 1720. Here's this thing, it's quite a bit lower, and that is the carbonyl carbon. Amides show a strong absorption, 1640 to 1680. If there are hydrogens attached to the nitrogen of the amide, there will be a nitrogen-hydrogen absorption here around that 3300, 31, 32, 33. But this should be a good example of one of the points we talked about on Wednesday. So what about absorptions above 1720 esters? So here's a carboxylic ester. 15 wave numbers above 1720. Maybe that doesn't seem like a lot. So here's ethyl octanate, 1738. Now here's something interesting. Looks like a ketone, but it's the highest up here. Strained cyclic ketones absorb at a higher frequency because the angle strain on the carbonyl results in a stronger, stiffer bond. Carbon nitrogen stretching 1200, 1660, 2200. Here's this carbon triple bond. Notice at the same position, but this is kind of weak. These are usually strong. That means their absorption goes all the way down towards the bottom. So here's our carbon triple bonded to nitrogen, and it's relatively strong. When we looked at the alkyne, it only came to about this far down. A carbon nitrogen triple bond has an intense, that means a long ways down, and sharp, that means a narrow peak, centered around 2200 to 2300 wave numbers. Nitrile bonds are more polar than carbon-carbon triple bonds, so nitriles produce a stronger absorption than alkynes. So here's some summary of stretching frequencies. So notice that one slide, it said 1200. This fingerprint region we kind of ignore for functional groups. It's more from here to here. It's where we look for functional groups. And here's these broad peaks, alcohols, carboxylic acids, aldehydes, and right here is our carbon triple bond, which is going to be shorter. carbon, nitrogen triple bond. They're both kind of pointy, and carbonyl carbons, and some of these others. So on a quiz and the exam, you get something that looks like this that I print on the back, and this is a stretching table. So when you look at a plot, you're not just out there in the dark. So the alkane just below this is the thing every IR Spectra has, and we ignore. All these are little clues to figure out what we have. Carbonyl carbon, 1720. You can see 1710. Close enough. So ketones and acids in this range. Notice you're told esters are a little bit higher, amides are lower. So all that stuff we just talked about, you don't have to memorize it. It's good to be aware of it, and then when you have this in front of you, it'll help you solve a structure. 1660, conjugation lowers. Esters, ethers, and alcohols also show a carbon oxygen stretch down here in the fingerprint region. You took psychology maybe? And so sometimes students, when they look at an IR spectra, they throw up their hands in desperation and say, I might as well be looking at one of these, telling all my past because of what I see here. Well, it's not really that bad. So I made sure I had a bunch of different colors. We don't seem to keep all the color stock that we used to have. I'm gonna go with black. 1600, 600. And if you've looked at some of these, you notice they're not, it seems to be a logarithmic scale, meaning my lines kind of get closer together. 4,000 over here. Let me see if I can fit everything in. 25. So I'm gonna draw a typical spectrum. And what do you think this is? Yeah, it's an alkane. So here's red. And of course, everything has one of those. I make that come down. And we don't really care about any of this. There's an alkene. Too bad my red is so horrible. That's the carbon-carbon double bond. And right here is this is if we have a terminal alkene. Maybe I should have used orange. And all these peaks over here, we don't hunt around on the stretching table. And that one PowerPoint slide, it said some stretching was at 1200. I don't even remember what it was. All I could think about is students objecting. And I want this in the middle-ish. Oh, everything has this. So this isn't necessarily drawn to scale. So there's our alkyne. A terminal alkyne, you'll see these hydrogens. Yes. If you have some internal, you'll still see these, but you won't see these. When you have a terminal alkyne, you'll see this stretching. When you have a terminal alkene, you'll see this stretching. These are not terminal alkenes or alkynes because there's no hydrogen bonded to the triple bonded carbon, or more importantly, to the sp hybridized carbon or the sp hybridized carbon. All right, next up, there's the ketone, and there's the alcohol. Any question? I guess I have purple. Same type of thing. Still got carbonyl carbon. Well, that's it. We'll be moving on to mass spectrometry.